Hi children, welcome back to that is your YouTube channel Physics by Imagination. So in this class we are going to understand about electric potential, potential difference, potential due to charge, a single charge, potential due to electric dipole, potential due to system of charges, equipotential surfaces, electric potential energy for system of charges and system of triangle system. So let us learn without wasting time. So first one is, what is electric potential? Dear children, potential means what? That is to move. So electric potential means what? The amount of work done to be given to the charge. Means now charges are moving from one point to another point. Okay. So but here the amount of work to be done to the charge which comes from infinity to one point, or which goes from one point to infinity against the electric field, that is called electric potential difference. Okay, or you can call electric potential. So electric potential means the amount of work done to bring the charge from infinity to one point, or from one point to infinity, that is against electric field or electrostatic force, and which is independent upon path, means which is not dependent upon path, independent on path. So next here, potential difference, just the amount of work done given the charge to move from point A to point B. Here the charged particles are moving from point A to point B. Then the potential difference between these 2 points is called, that is voltage. That is voltage. And the major source of potential difference is battery cell. Okay. So now here, what is potential difference means the amount of work done to bring the charge from one point to another point, means that is potential difference. If I bring a charge from infinity to one point, or one point to infinity, that is against electric field, that is called potential difference. This is all about electric potential and potential difference. Dear children, electric potential and potential difference over potential due to a charge. So let us consider here there is a charge and with 1 coulomb of charge. Then here, how can we move the charge from point A to B at a point P and distance is R? Very simple diagram. Now we know that according to Coulomb's law, the force of attraction or repulsion between the two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of distance between them. So that if I apply this law here, so according to Coulomb's law, we can write that is K into Q into 1C divided by R square, because your charge is 1 coulomb. So it becomes force is equal to K into, that is Q divided by R square. This is called equation 1. Now here, the amount of work done we have supplied to move the charge infinity to 1 point, or 1 point to infinity, that is against the electric field. So that is, we know that work is equal to force into distance. So here distance will be dr. So force, we know that, always remember this force and work done are inversely proportional to each other. So it will come opposite to each other. So minus F. So because they are opposite to each other, then it becomes W is equal to F value will substitute here, K into Q divided by R square into dr. So this is amount of work done. Dear children, I want to find potential difference, and this amount of work done is equal to potential difference. So then I am going to integrate, that is dW or dV, dW or dV, this is dV, this is differentiation with respect to change in potential, this is change in work done. So if I integrate means what I am going to get, integration of minus K and q is constant, integration of divided by 1 by r square dr. So now here integration of, we know that x to the power of n, that is dx is equal to x to the power of n plus 1 divided by x to n plus 1 plus c. So here if r square will go to numerator, it becomes r to the power of minus 2 plus 1 divided by minus 2 plus 1. It becomes, already minus is there, minus of minus it becomes plus. That becomes potential difference is equal to k into q divided by r. Dear children, what is k? That is proportionality constant. That is equal to 1 by 4 pi epsilon naught. So this is all about, we understood the potential due to a single charge or isolated charge. Okay, so V is equal to K into Q by R, and this is inversely proportional to distance. If distance decreases, electric potential will increase. So after that, let us come to the point. Next, what is there here? Potential due to electric dipole. So you know that yesterday we discussed that what is dipole? Two equal and opposite charges separated by small distance, that is called electric dipole. So separated by small distance. Then what is going to happen, children? It is going to have a permanent dipole moment. So observe carefully, children. It is going to have permanent dipole moment. They are called polar molecules. Now what is my point here? It is the amount of work done to charges move from one point to another point. That is, or from infinity to one point in this system. That is directly given by formula. V is equal to, that is 1 by 4 pi epsilon naught p cos theta divided by r square minus a square cos theta. Very important, children. Directly it will ask you in the examination. So now here, this is the electric potential due to dipole. Now what is my point, children? We are going to find the cases. So now we discussed electric field due to dipole along the axial line. Here potential due to at a point on the axial line is given by, that is, if theta is equal to, axial line means we are going to consider horizontal position, then theta is equal to 0 degree. Then what happens here? We know that cos 0 is equal to 1, cos 0 degree. Then expression becomes V is equal to 1 by 4 pi epsilon naught P divided by R square minus A square, which is very similar to, that is, expression of, that is, axial line, electric field due to axial line. If I consider a equatorial line, it is perpendicular to each other. If then, this is case 1, if theta is equal to 90 degree, then what happens, children? The electric potential in dipole, that becomes V is equal to cos 90 is equal to 0. The total electric potential in this system, which is going to become 0 volt. Now here, this is all about, we understood electric potential, potential difference, potential due to charge, potential due to electric dipole. Now potential due to system of charges. So and here, let us understand what is the unit of potential difference. So dear children, it is very easy. What is potential difference? We can give in simple equation, that is, potential difference is equal to W by Q. Or we can write, we are done 1 by 4 pi epsilon naught Q divided by R. Just we got the expression. Now here, this is, when I supply 1 joule of work, then 1 coulomb of charge will be moved. That is called 1 volt of potential difference. Okay, so now come to the point, potential due to system of charges. The children, imagine in this system, number of charges are there. Okay, at a point P. Then the potential at point, that is, the potential due to at point Q1 is given by, that is, V is equal to K into Q1 divided by R1P. Similarly, V2 is equal to K into Q2 into R2P. Means, that is, we are going to take a reference point and we are going to find a potential. If I add, means it becomes V is equal to K is constant, that is Q1 by R1P plus dash dash dash, This is Qn divided by Rnp. This is the formula for electric potential due to system of charges. Please note down, children. Next, after this we come to the point equipotential surface. Here, what is the meaning of equipotential surface? Equi means what, children? That is same. Potential means what? The amount of work done to bring the charges from one point to another point. So as the name itself indicating that equipotential surface means if I consider a surface, any charged surface of the body, then if I keep any point, then that V is equal to same, means the potential difference at every point is same on the surface of the body. That is called equipotential surface. Then we are going to discuss about properties of equipotential surfaces. So what is here? Always here suppose 1 volt, 1 volt, 1 volt. So here we are going to see the equal amount of potential difference, children. So that what is first point? That is the amount of work done in the equipotential surface is equal to 0. Why? You know that is potential difference is equal to work done by charge. Now work done is equal to potential difference into charge. So the potential difference is nothing but what? Difference between the two voltages, that is called potential differences. That is VB minus VA or VA minus VB. So then this is 0 means 0 into something is equal to 0. So that the amount of work done in the equipotential surface which is equal to 0. This is the first point. Second point, and this direction of the electric field is always tangent to the equipotential surface. Okay, now this is electric field direction is always tangent to the equipotential surface. So this is tangent is equal to electric field. So third point. What is third point, children? This is they do not intersect together, because everywhere we are going to find same potential difference. So they are not going to intersect together. So that is do not intersect together. Now children, we are going to take that is very simple concept. Equipotential difference is going to find number of electric fields, which may be strong electric field or weak electric field. So let us consider that. So the fourth point we'll discuss now, that is how does equipotential surface is going to mention about whether the potential is stronger or weaker. Let us take two charges, that is repulsive, they are unlike charges. Then the difference between the potential of these surfaces will go on increases. Then if the distance between the equipotential surfaces will be increased, means that is going to have lower amount of electric field. Lower amount of electric field. If I take unlike charges, then the potential surface are going to be decreased. Then if potential difference between equipotential surface are going to be decreased, then what is going to happen, children? That is going to be have higher amount of electric field. We know that the relationship between electric potential and electric field, that is E is equal to minus dV by dx. Numerically E is equal to dV by dx. So dx is nothing but distance, that is inversely proportional to E. It means what, children? If distance will decrease, that is going to have stronger electric field. If distance decreases, means that is going to, distance dx is inversely proportional to V. If distance will be increases in the equipotential surface, electric field will be having weak amount of electric field. If distance decreases, means that is going to have stronger amount of electric field. So this is all about equipotential surface. Now electrical potential energy for two charges and triangle system. Please note down that. Okay, so I am repeating once again, very important in CET. What is the first property? That is very simple. The amount of work done is 0 in the equipotential surface. They do not intersect together, and direction of the electric field is always tangent to the equipotential surface, and which determines the amount of electric fields. So now, what is potential energy? You know that just we are going to give the work, then charges will move from one point to another point, that is called electric potential energy. So now, electric potential energy at a point in the electric field is given by, that is, which energy is equal to product of charge into potential. So this is electrical potential energy is nothing but product of charge in potential difference. This is very useful, children, in the CET. E is equal to Q into V. Now if amount of work done, that is dW is equal to Q into V, and I am going to consider a test charge which is very negligible and which do not affect the electric field. Now this is from one point to another point, potential difference. This is potential energy. Now here, if electric potential energy is decreases, then kinetic energy of the electrons will be increased. So this is very important point, that is the decreasing in potential energy is equal to increasing in, that is kinetic energy. Okay, this is m is mass of the electron. So this is very important relation. If potential energy decreases means kinetic energy will increase. This is all about electric potential energy. So next of charges, two charges. Let us consider two charges, children. That is charge with presence of electric field, without presence of electric field. Let us consider a electric potential due to two charges, that is Q1, Q2 separated by distance R. So potential difference means what, children? That is potential energy. I told you it is a product of electric field, that is charge into potential. Charge into potential. So we can given by equation, that is Q2 Q1, means here there is the absence of electric field. We are not going to bother about electric field. Then what is going to happen? Then the potential difference, it is given by potential energy is given by, that is we are bringing this charge from infinity to this point, that is point A to point B. So means we have brought the charge from infinity to this point B. Then Q2 for Q1 is given by, so the T difference is given by, that is K into, that is Q divided by R. This is Q1. We are bringing this charge from this. Then we know that is potential difference is equal to W by Q. Now W is equal to V into Q2. This is Q1. Then what is going to become? W is equal to, that is what is V, that is K into Q1 Q2 divided by, that is R. So this is the formula for potential energy or amount of work done in the, that is absence of electric field. Please note down, children. So after this we are going to discuss about, that is electric potential due to, that is in the presence of electric field. So in the presence of electric field, that is your electric field is present, then this potential energy is nothing but the potential energy of two charges, that is in the absence of electric field, in the absence of electric field, plus potential energy at point A, that is Q1 at A, and potential energy at Q2 at B. So we know that potential energy at Q is nothing but the product of charge into potential. So we know, just we got the expression, that is potential energy in the absence of electric field is equal to given by, that is K is equal to Q1 Q2 divided by R. Then this is Q1V Q2V. So this is the potential for potential energy that is between the two charges in the presence of electric field. That is potential energy is equal to K into Q1 Q2 by R, Q1 V plus Q2 V. Here what is K? That is equal to 1 by 4 pi epsilon naught. Please note down, children. So afterwards we are going to discuss about last point, that is potential for triangle system. This is very important, children, for CET. So here what is going to happen? Potential for triangle system, and also it is very useful in Neet. So let us take Q1, this is Q2, this is Q3. Three charges are there. Now this is, I'll call as R12, this is R13, this is R23. So we have got the expression, that is the amount of work done, that is equal to potential difference is equal to what you can write, that is this is from Q1 to Q2, that is given by equation just now. This is nothing but electric potential energy, not potential. Sorry children for that. Electric potential energy. Electric potential energy. So that is, dear children, now we are going to understand about electric potential energy due to triangle system. Let us consider Q1, Q2, Q3 are the three charges, and this is separated by distance R12, this is R13, this is R23. Now just now we got the expression electric potential energy is equal to 1 by 4 pi epsilon naught, that is K into Q2, Q1, Q2 divided by R. Or we can write 1 by 4 pi epsilon naught Q1, Q2 divided by R. Now that is for this one we are going to give, that is W12, the amount of potential energy from year to year given by, that is K into Q1 Q2 divided by R12. Similarly from year to year given by, that is W13 is equal to K into Q1 Q3 divided by R13. Similarly from year to year, that is year to year we can take 2,3 is equal to the potential energy. 2,3 amount of work done is nothing but potential energy, children. So this amount of potential energy is equal to K into what is going to happen, children. This is Q2 Q3 divided by R12. If I take K constant, I am going to get the expression, that is total potential electric potential energy is equal to K into Q1 Q2 divided by R12, Q1 Q3 divided by R13, that is again Q2 Q3 divided by R23. This is about these topics. So next class we will discuss about remaining topics. I hope you understood, children. Okay, please if you like, please share and subscribe. Thank you.